So here's our quotient rule situation here. The inner function is 2x squared plus x, and our outer function is the 3. So therefore, the quotient rule says, let's write the quotient rule out. So it's f prime of g of x times g prime of x. So it's the derivative of the outer function f, leave the inner function the way it is, times the derivative of the inner function g prime of x. So the outer function is the cubing function, the inner function is the 2x squared plus x. So we take the derivative of the outer function, which is exponent comes down up front, leave the inside, subtract 1 from the exponent is 2, so leave the inside the way it is, times by the derivative of the inside, which is 4x plus 1, in parentheses. Now I'm just going to distribute this 3 with this 4x plus 1, and then that'll be the end of that. So we get 12x plus 3 times 2x squared plus x quantity squared. Our next one's chain rule again. We have the outer function is not cubing, but to the negative third power. Our inner function is just x plus the square root of x. The square root of x is kind of ugly, so I'm going to rewrite it. So it's x plus x to the 1/2 to the negative 3. So our outer function is derivative of to the negative third power. Power rule, bring the exponent down, subtract 1 from the exponent. So our derivative will be negative 3x plus x to the 1/2 to negative 4th times the derivative of the inner function. Well, the derivative of x is just 1. The derivative of x to the 1/2 is the exponent comes down. Subtract 1 from 1/2, you get negative 1/2. And there you go. So now I'm going to move this down into the denominator. So I get dy dx equals negative 3. I'm going to write this as, I'm going to move this x in the denominator of the 2. So this is 1 plus 1/2, 2x to the 1/2. All over this whole thing gets moved into the denominator. So it's x plus x to the 1/2 to the 4th. Now I really don't like having a complex fraction, which is a fraction inside of a fraction. So I'm going to multiply this whole numerator times 2x to the 1/2 and this whole denominator times 2x to the 1/2. So I'm going to multiply this 1 and then this, and then I'm just going to put this up front. So we get dy dx equals negative 3, 2x to the 1/2 plus, well, these two cancel, you get 1. And I'm just going to put this thing in front. So 2x to the 1/2, x plus x to the 1/2 to the 4th power. Pretty unattractive. Too far. Here's a little chain rule with a trig function. So our outer function is negative 1. Our inner function is secant tan. So our derivative, the outer function is negative 1, so we bring the exponent down and subtract 1. So that would be negative times negative 1 secant of x plus the tan of x to the negative 2 times the derivative of the inside, which is secant x. Derivative of secant is secant tan. Derivative of tangent is secant squared x. I'm now going to move this to the denominator. I'm going to negative times a negative is a positive. So I'm going to rewrite it as f prime of x is equal to, this goes in the denominator, this goes up top, this becomes positive. So secant x tan x plus secant squared x all over secant x plus tan x quantity squared. Notice a common factor of secant. So f prime of x equals secant x tan x plus secant x all over secant x plus tangent x quantity squared. So notice this cancels with one of those. So my derivative is just secant x over secant plus tan. There you go.